Okay, we just completed lesson 7, exercise 3, and this is for lesson 8, exercise 4. So I'll just go ahead and rename this real quick. Lesson 8, exercise 4. And in lesson 8, exercise 4, if I have this right, we're putting lesson 7, exercise 3, and lesson 7, exercise 5 together. Now, when I go to do, oh boy. Okay, so we got lesson 7, exercise 3 we're doing, and then this should fall under lesson 8, exercise 4, assembly. I'm going to double click on that just to get in there and make sure I'm in that one. What have I done? What have I done? For some reason, I'm not able to rotate my part. What just happened? Okay, got my part working again. So I want to build the part that's going to touch flush to this face. That is why, since this face is touching the other face to the other part, I want that to be my datum. And the bottom's going to be the same. So the same bottom on both parts and the same left side on both parts. If you look in the book, they datum dimensioned on part number lesson 7, exercise 3. They datum dimension from the left to the right. But when you look at lesson 7, exercise 5, they datum from the right to the left. Well, that's going to create all kinds of crazy problems. So you don't want to dimension that way or datum that way. I wouldn't want my local axis system over here on this side. Okay? I want my local axis system to start at the exact same point and be the face that's touching this part here. So what I would do is, you're in the part design workbench right now. We got to switch back to assembly design by double clicking the assembly in the top collector. That will put us back into the assembly design workbench up here in the top where my cursor is flashing. So now that we're in the assembly workbench, we can insert another part. So this part here is going to be lesson 7, exercise 5. And again, I should have no spaces. Okay. Open that up. And I need to create that local axis system. So I could go to axes. What the heck is that? Oh, I'm still at the assembly, sorry. I created the part and I got to get into the part. I'll double click this part. Make sure you double click on the 3D shape so it goes into the part design. Now that I'm in the part design, I could create an axis, wireframe, point, and I could insert those same point coordinates I did from this table here. Or what I could do, I can't copy the local axis over here, but I can open up the geometrical set and double click on that geometrical set to swap geometrical sets. Okay, and then on this point I can copy that point, and I could double click this geometrical set to pop into this lesson 7 exercise 5, right click and paste, and now I have that point, these same coordinates as I do over here. So I know I have the same point at the same coordinates. So when I hide lesson 7 exercise 3 just to get out of my way, I still have that point sitting right there, and I can go to axis and create on that point. I'll just pick it out of the tree. Sometimes it's harder with my cursor to get that. Now this becomes the local axis. Under feature properties, we're going to say axis system. L7 dash 5, and I will call it local. Okay, so it's the local axis 7-5. So when I'm going through and I'm starting to get complicated here with all the different local axes I have for all the different detail parts in my assemblies, I can use the name to help me distinguish one from the next. Okay, so here I have that local axis system. I'll go back to view, ISO view. Oh no. How did I do this? Somehow my tree there got activated. I'm going to hit ISO view. Select this plane. Go to sketch. And on the other one, that should be the same size, I believe. Oh no, this is a little bit taller. So we're going to do a sketch and go to rectangle. I'll just start here. And for the width, it's 5.5 tab, 3.5 inches tall. Okay, and then we have that rectangle that starts 1.5 inches over, goes up 1/2 inch, and then over 2.5 inches. Something doesn't look right. Right there, that's 2.5 inches. I'll go right to auto constrain. Ah, I missed. Oops. I did an undo. I'll do a redo to bring it back. I'll go to auto search to grab that rectangle and hit auto constrain and just say OK. And just like that, it's constrained. I'm going to highlight this, hit auto constrain and say OK, and that's going to coincident those and locate this for me. I know it's constrained, so if I grab the edge, the whole thing moves. So I'll undo that, put it back to where it was. And then I'll highlight the corners, and that is going to be 1.5 inch radius. And then we're going to create our circles, which are concentric, I believe. I'll just create them. I don't know what size they are. It's like that point, and then I'll do another one to the center here, concentric. Slide that out. Oh no, that's not that case, sorry. We are going from here up, and I'm going to highlight that circle. Now highlight just this circle. Just want to show you something here. I can go to auto constrain, and I want to dimension it from here and here, and say okay. So it locates it for me. Everything should be set. That is to be 2.5 inches tall with a radius of 0.75, which would be a diameter 1.5. This is supposed to be 3.25. Okay, and then I think that's everything. We will go to contact this to this, contact this to this. It's not holding concentricity. I wonder why. Let's try and auto constrain that and reference from here and here, and we're going to stack or chain dimension it. Well, what it did, I guess when I created it, didn't lock in concentricity, so I just locked in concentricity now. So remember, geometrical constraints is the first thing it's going to do. Something does seem off though with what I've done. Is that the right radius? This dimension must be 1/4 inch. You don't call off 1/4 inch radius for these cylinders. I should be calling off the diameters, in which case that would be a 1/2 inch diameter. Same on the other side. It's 5.5 inches, 3.25 inches tall, 2.5 inches up. I don't know why I'm not seeing what's wrong with this, but for you guys, the concept of what we're doing, the exercise should be the same. I click off the sketch so it's no longer highlighted, and we're going to look for pad. Can't believe I did that again. Let's cancel this. I want to just drag and drop this over here. I wonder why I'm having so much challenges here moving this thing. I'm going to drag and drop this sketch over here so it's in the part body. We'll go to pad. The key again is you got to make sure the sketch is not highlighted. I'm going to grab this here. One thing I forgot to do is in my sketch, always want to analyze it. I'm looking for constrained and all closed profiles. So since everything's closed, they'll all have their own sub-elements to make pads with. And then I'm going to go to, whoops. See, I got the whole thing highlighted and it's confused. Doesn't know what to do. I'm going to go to pad. Go to profile definition. Select this one. And I'm going to reverse the direction, and I believe it's a 1/2 inch. And the reason why I'm reversing the direction is this face has to touch, oops, has to touch that part. So that's a datum, and the face that's touching is the datum. Alright, so I'm going to go to pad, go to profile definition, select OK, and the length in the book is short. I want to go 2 1/4. And the reason why I'm going 2 1/4, so I can see that thing's got to stick out. If I went to 2 inches, it goes flush to this. Okay. Now, this pin here sticks out at 1 1/4. So we go back to pad, go to profile, and these two pads are the same. Those two pins are the same distance. So I might as well do them at the same time, and they come out 1 inch from the front face. And when I go to pad, go to profile definition, this pad goes out a distance of 1 1/4, so it's a little bit more. Okay, so now let's see what I did wrong here. I'm going to pull this out. Oh, you know what? I made them concentric, and I don't think these are concentric. They're not. So I'd have to go back and fix that. Anyways, that's the concept, though, to doing the lesson 7 exercise 4 assembly. Once you got the part assembled, you can then make a drawing of that. So hopefully you can see why you want to have a local axis system. The local axis system establishing the datums on both. The more you have in common, the more likely your parts are going to mate.